All right, guys. Hope you all are enjoying your snow day. I'm sure you're thrilled that I'm having y'all do a lesson, but we gotta keep going, and plus this will be good for you. So, as we started in class last week, we are talking about applying the laws of sines, and we started out with this problem here, and we kind of talked through it. Some of y'all who had watched that pre-lesson video figured out how to do this using the law of sines, but figured I would go through our notes just as another video to help y'all out. So here we go. So laws of sines, what it is it's a way to find out measurements when triangles are not right. Because if we've used our trig ratios, we know those are always for right triangles, where you can use our sine, cosine, tangent. So laws of sines help us when we want to find either the angles or the side lengths of triangles that are not right. So what the laws of sines says, it relates the sine of each angle to the length of the opposite side. So if I have sine A here, sine of A over the distance of A, so sine of the angle over the distance is going to be equal to sine of B, this angle here, to the distance of B, lowercase b meaning distance, uppercase meaning angle. And then it would also be proportional to the sine of C, angle C, to the opposite side. Okay, so why does it work? All right, so I just want to kind of walk through just to kind of show where this comes from. So, let's start out by just taking sine of A, right? So if I have this right triangle here, I know that sine of A, we just use our trig ratios, is going to equal opposite over hypotenuse. So I'm just going to apologize now. My handwriting, because I'm having to use my trackpad, might not be that great. So sine of A equals H over B, right? Opposite over hypotenuse. Okay, now we want to solve for B. We want to get B alone. All right, so how do I get B alone? I multiply both sides by B. Oh, I'm sorry, we don't want to get B alone. We're going to get H alone. My bad. We're going to get H alone. Okay, so I'm multiplying both sides by B, and then I get B times sine of A equals H. Okay. So then let's do it for sine of B, right? So sine of angle B, okay? Again, what I'm showing you here is just why it works. What I'm showing is not going to be anything that you are going to be required to kind of do here. I just want to show you where this derives from. So sine of B, again, is going to be opposite over hypotenuse. So now H over A, okay? The opposite over the hypotenuse. Okay, so then again, get H by itself, just as I got H by itself over here. So multiply both sides by A. So then I'm going to have A times sine of B equals H. Okay. So if you look at these two, B times sine of A equals H, and A times sine of B equals H, they both equal H, right? So then I can come over here and I can make this statement that B sine of A equals A times sine of B. And all this is after I have cross multiplied sine of A over A equals sine B over B, right? Because if I were to cross multiply, B times sine of A equals A times sine of B. All right, so again, this is where it derives from. Okay, this is why it's true. If I'm looking at a triangle that is not right initially, I know that I can always form a right triangle by bringing down the altitude, and it creates three similar triangles, which we talked about last unit with our geometric mean. And so this is where it comes from. Okay, so I just wanted to show that before we actually start doing some problems. Let's go to example 1. So what is the length of side BC, right here, to the nearest tenth? All right, so I'm giving you two angles here and one side. Okay, so when we do laws of sines, there's two different ways we can do it. This is an example of angle, angle, side. Okay, so I'm given an angle, and a side. So when you're given angle, angle, side, you know, okay, this can be laws of sines. All right, so let's start. Let's if you're looking to see what I have, okay, I have angle at B, and then I have the side opposite of B. I have angle A, but I don't have that, and that is what I'm trying to find. So we'll call that A. So I know I can set up sine of A over A equals sine of B over B. All right, so let's go sine of 48 degrees over A, and then have that equal to sine of B, no, I'm sorry, sine of, what is that, 93? All right, sine of 93 over 15. Okay, so I want to cross multiply here. So when I cross multiply, I get I get 15 sine of 48 equals A sine of 93. All right, so what I did here is I did 15 times sine of 48 equals A times sine of 93. Okay. Now I want to get A by itself. There's the bell. All right, so then I want to get I want to get A by itself, so I'm going to divide both sides. Ooh boy. Of sine of 93. All right. So then in your calculator, you'll do be sure in your numerator, you have 15 sine of 48. So I definitely use the n over d feature, have 15 times the sine of 48 on top. And then be sure you put sine of 93 in your denominator. And when you do that, A is going to come out to 11 and 2/10 rounded to the nearest tenth. All right, so then we know that A equals 11 and 2/10. Okay, so that's using laws of sines. All right, so we're going to do another example here. This time I'm not giving you the triangle. I actually already put that in your notes. You will not have that there. I just kind of drew it. And we'll say in angle KLM, so I'm just going to randomly call this KLM, okay? And I know that KM is 14, so just draw a little picture here. LM is 9, and I know that angle L is 105. Okay. So now I'm giving you two side lengths and one angle. So this would be an example of SSA, right? So if we go back and think through, the last example was angle, angle, side. This is a side, side angle, okay? And so these are the two different ways for laws of sines, okay? We're going to get to laws of cosines tomorrow, and you'll see the difference of when to use which, okay? So again, angle, angle, side, and side, side, angle, okay? All right, so here we go. So we're going to so we look to see which angle am I trying to find. It says, what is the measure of angle K? So this is K right here, all right? Oh boy, all right. So angle K right here. So this is what I want to try to find. And again, I see it, I'm opposite of 9, and I have L, which is 105, which is opposite of 14. So again, I'm going to start out by going back and doing sine of A of angle A over A equals sine of B over B. Okay. So sine of A, we'll call that sine of 105. So sine of 105 over 14. And that's going to equal sine of angle K, the angle I don't have, over opposite of K is 9. All right, so then we want to cross multiply. So I have 9 sine of 105 equals 14 sine of K. All right. So just like on the last one, we want to get sine of K, the variable, by itself. So I'm going to divide both sides by 14. All right. So then I'm left with sine of K equals 9 sine of 105 over 14. All right, so this is where, if y'all could talk back to me, I would be asking you, okay, so what do we do now? We're trying to find an angle, and hopefully you remember that anytime we find angle measures, we are using the inverse, right? So I use my inverse trig ratios when I find an angle measure. So now I know I'm going to say, okay, so sine inverse, and then parentheses, I'm going to put in 9 sine of 105 over 14. Okay, so I take my calculator, plug in 9 sine of 105 over 14, and as the inverse, and then I'm going to get, I'm sorry, this equals K. So when you do this, we would get K equals 38 4/10, round nears 10th degree. Okay. So that's laws of sines. All right, there's one more example, but I'm gonna let you do that one on your own, but I will tell you what the answer is, just so you can check your work. So this is a great football question. A quarterback, linebacker, and a wide receiver are positioned at on a football field as shown in the figure. If the linebacker sprints to tackle the quarterback, how far must he run, right? So if you're looking, so what we're trying to find how far the linebacker is to the quarterback. So this right here is the angle that we don't know. So you can just call this, I'm sorry, the side length that you don't know. So you can call that A. So you're going to want to start out by doing sine of 44 over A. Oh, no. Okay, so look, 50 I'm given here, but I don't know that measure. I don't care about that measure. What I care about is this angle. So how am I going to find that angle measure right there? Well, 50 plus 44, and then subtract that from 180, so you'll figure out what that is. And then that will be your angle. So you set up sine of whatever this angle is, you can figure that out, over 13 8/10 equals sine of 44 over A, and solve for A. And just so you know, when you do this work, I want you to practice it. The answer will be 9 6/10 yards. Okay. All right, guys. Enjoy the rest of your day. I will be seeing you tomorrow. Be sure you come to class prepared with your homework. It's on the homework sheet. It is the assignment that was originally supposed to be due on the 11th. So it's the one, it's 8-5, page 525 to 526, number 7 through 14 and 16. All right, guys. Have a good one.